aluminium anodizing. Detailed explanation of reactions and processes occurring during aluminium anodizing. Aluminium is a metal with highly valued properties such as low specific gravity, good mechanical qualities, and its exceptional decorative aspect. Because of such properties, aluminium holds a privileged place in various industrial applications, especially in architecture. These applications increased in part because specific aluminium alloys have been created, some having remarkable purity and corrosion resistance properties. The road to obtain such impressive results with aluminium was long. Initially, it was observed that the aluminium surface, subjected to weathering, becomes coated with a thin natural oxide film, able to passivate and protect aluminium against corrosion, even if that protection was not long-lasting. This observation triggered a research process aimed at obtaining an artificial oxide with superior corrosion resistance and stability properties. In 1911, this research led to the filing of a patent that before long represented the most widely used process of aluminium finishing in the world, electrolytic anodizing in a sulfuric acid solution. The steps in this process are as follows. First of all, the surface to be anodized is degreased to eliminate oils and greases deposited on the surfaces during previous processes. It is then rinsed with abundant water. After, an etching solution or chemical brightening is used to eliminate the natural oxide and make the surface appearance more uniform. The subsequent step is a rinse, followed by a neutralizing phase to eliminate the residues of the previous treatment solution. Further rinses are then performed to avoid contaminations due to carryover of the previous solutions into the subsequent phase and to obtain a clean surface. At this point, the surface is ready for the anodic oxidation phase that is carried out by immersing the aluminium piece in an electrolytic solution. The term anodic oxidation derives from the fact that the oxide layer forms on the pieces to be treated without depositing other metals or products on the surfaces, simply by placing the aluminium at the anode of the electrolytic tank. Anodizing is obtained by passing direct current through an electrolyte solution. In these conditions, the positive H ions and the negative OH ions of the electrolyte solution move toward the cathode and the anode respectively. After a few seconds of current flow through the electrolyte, oxygen develops at the anode that reacts with the aluminium, forming the aluminium oxide layer on its surface. The first layer of aluminium oxide is compact and continuous, making the subsequent passage of current difficult. This is called the barrier layer. Due to the continuous application of electrical current and the solvent action of the electrolyte solution, a series of attachment points begin to appear on the barrier layer, each corresponding to the origin of a pore of the anodic layer that is forming. Let's examine what occurs in these attachment points. Because they formed on the barrier layer before the oxide layer reached its maximum thickness, it becomes evident how the passage of electrical current was facilitated by the attachment points. The current is distributed in a radial manner with respect to the pore, which will have a semi-spherical shape, so that the various columns of oxide in formation assume at first a cylindrical form, in whose axis we will find the pore. Finally, due to the equidistance between the pores, these cylinders will transform into hexagonal prisms. At the end of the process, a layer of aluminium oxide is formed that is perfectly adherent and chemically bonded to the metal base. It is important to note that there is no kind of coating on aluminium or any other metal that has the same adherence as the anodic film that forms in the process of anodic oxidation. When the anodic layer is formed, another rinse cycle takes place to remove any possible residues of acids from the anodizing solution from the pores. At this point, there are two possibilities. If the natural color is requested, the coloring phase is skipped and you go directly to the subsequent rinsing and sealing phases. If, on the other hand, a coloring is requested, you go to a phase in which metallic salts or chemical compounds are deposited inside the pores of the anodic layer to produce various tonalities of light-resistant color. The most common processes of electrolytic and immersion coloring follow the directives of the Qualinod quality label. When the anodic layer is formed and the coloring process is complete, the pores must be sealed with a sealing treatment. First of all, a careful rinsing with water is essential. A second deionized water rinsing follows to completely remove any acidic residue from the pores. Finally, the porous structure must be sealed. This is an extremely important step to obtain the highest levels of resistance to corrosion of the anodic layer. One can only have the total assurance that the anodizing process has been carried out correctly if the anodized materials follow the Qualinod specifications. The sealing of the anodic layer consists in hermetically closing the pores of the oxide, utilizing one of the two systems suggested for the Qualinod quality label. These systems are respectively hydration and impregnation. In hydration sealing, when the anodized aluminium is placed in the relative tank, the pores of the anodic layer are still open. Using deionized water or steam, the aluminium oxide begins to hydrate and increase in volume, thus causing the complete closure of the pores. In impregnation sealing, the closure of the pores is obtained by immersing the anodized aluminium in a tank with deionized water containing mineral salts that deposit in the pores. The result is a chemical reaction that totally closes the pores. Both systems produce an anodic layer that is highly resistant to abrasion and able to protect the aluminium from atmospheric corrosion. The anodizing process is the sole treatment that fully protects the surface of aluminium while preserving its identity.